Hello everyone. So today we're going to be learning about 11-3. So 11-3 is about finding integral of trig functions. Integral of trig functions. Okay, now first I'm going to show you derivative so that you and then I'll talk about integral after. Then it's going to be easier for you to actually make that connection. So I'm just going to make two different columns. So basically integral is just undoing derivative. So on the right hand side I would put derivative equations, and on the left I would put integral. So now try recalling the first one. The first rule we did for derivative was derivative of sine function. What was that equal to? Cosine. And now if you see cosine integral, so it's nothing else, it's going to be sine x, but don't forget to add a constant at the end. Second one, if you take derivative of cosine function, it's equal to negative sine function. So undo, if I see sine x, it's going to be equal to cosine x and add c at the end, but don't forget you need to adjust that negative anywhere in the equation. If the original function is positive already, then I would make this cosine negative. Okay, next one, if I have derivative of tangent function, what is that equal to? It's equal to secant square x. Now undo, if I do secant square x, that's going to be equal to tangent x plus c. Next one, if I have derivative of secant function, what is that equal to? It's tangent and secant both, right? Now, since we are undoing it, so in order to apply this rule, you have to have both together. So tangent, secant together would be equal to secant square x, and there's plus c at the end. Next one, derivative of cotangent. It's equal to negative cosecant square x. Here's, if it's negative, if it's cosecant square x, it's going to be equal to cotangent x plus c. And don't forget, you need to adjust that negative, so I would make this one negative. And the last one, it was cosecant. What is that equal to? It's cotangent and cosecant, and there's a negative. So here's, if you see cotangent and cosecant, that's going to be equal to cosecant and plus c, and don't forget there's a negative. Now, I really want you to look at integral equations closely. There are a few things you actually have to understand. So first thing, if you look closely, I would say you literally have integral for just two equations, like two functions, because the rest of those equations are either it's square or it's kind of like combined with another function. So basically just sine and cosine, these two equations are obvious equation or literal equation you actually see the rule for, right? And the rest of the equation, either like this one here, this or this. In order to apply the property, you have to have square with the original problem. If not, then you won't be able to apply that property. And how about if I say, how about this one? Like this one here and this one. In order to apply these two properties, you have to have two functions combined. Like tangent should have secant to apply the rule. Same thing for cotangent. Cotangent should have cosecant in there. Otherwise, you won't be able to apply that. So that's where you need your fundamental identity. So if your function doesn't look like any of these rules, so you have to think about simplifying the function first and substituting with fundamental identities so that you would be able to apply these rules. Otherwise, it's going to be tough, all right? Anyways, today I'm going to show you a few examples. So basically, few examples just on pattern recognition. Because first, we always do pattern recognition first, and then we will go towards use substitution after. So if you want to follow along, I'm on page number 689, and I'm looking at example number 1. So example number 1, I have 2 cosine x dx. Okay, do we have any rule or property for cosine? Yes, sine and cosine, we already have the equation. We don't have equation. We do have equation, but those are slightly different, not direct equations. Okay, this one, I can pull out the constant, which is 2. So I can pull out the constant, take the integral of cosine x. What is that? Sine and plus c. Here you go, done. Next. Let me pick a different color. Let's just do school colors. Okay, next one. Nope, I tried doing yellow. Okay, got it. I have 3x to the second. Then I have sine x to the third, and it's dx. Okay, now first thing, this is something you could do to actually make this whole process way easier than normal. Try to identify your original equation. So original equation definitely going to be this function. Now, in order to complete the pattern, is the other part, the leftover part, derivative of the angle. So this is x to the third. What's the derivative of x to the third? It's 3x to the second, which is already there. So it means in order, this completes the pattern. So once this completes the pattern, remember, it just goes away, right? So now you just have to take the integral of the original function itself, because the other part is just there to complete the pattern. It just try to calling chain rule. That's how chain rule works. Original, and it gets multiplied by the derivative, right? So derivative is just going to go away. Original is sine x to the third. So what's the integral of sine of something? It's cosine with a negative. So it's going to be negative cosine x to the third and add c. All set. Next one. I have secant square. 3x is the angle, dx. Okay, first of all, identify your original equation. So the original equation is secant square with some angle. Do we have a rule for secant square? Yes, we do. What is that? It's equal to tangent. But now, since this angle is not just x, isn't it? It should have its derivative attached to it. So what's the derivative of 3x? It's 3. Do we have that number? No, it's not. So that's where we bring in the number. All right. So now the top number would complete the pattern, and later on it's just going to go away. And we would factor out 1/3. So what's the integral of secant square of some angle? It's tangent of that angle. Since I'm done taking integral, so I'll just erase this part. And now add c at then. Okay, I have 2 more. So let's say I have, this is example number 2 on the next page. So this one I have, it's integral tangent square x and it's dx. First of all, do we have literal rule for tangent square? No, we do not. In order to apply that equation, you have to have tangent and secant. So this one is not, right? So this is where you have to substitute this function with one of those fundamental identities. This is tangent square. You could do sine square over cosine square, but then there's no quotient rule, right? It's not derivative. So then I can think about, remember, tangent square, x is equal to 1 minus secant square, right? No, I'm sorry, it's the other way around. It's negative. It's secant square x minus 1. That's the identity. So let's just replace this function with that. So I have secant square x minus 1. Okay. Now this is just like normal equation. Now I do have a property for secant square which I can apply to this. So I would just integrate this function. So just take integral of every single piece like this. Integral of secant would be tangent x. Since the angle is just x, derivative would be 1. It's not going to make any difference. So it's tangent x. Derivative of just 1, it's minus. Derivative of 1 would be 1x or just x. And then at the end, I would add c. Okay, last one. It's integral of, it's cosecant x plus sine x. And it's getting multiplied by cosecant x. And there's dx at the end. Again, I have 2 expressions. For something like this, I can't even apply any property or any identities. So instead, I could just think about distributing. So let's do that. Cosecant times cosecant is cosecant square plus sine times cosecant. Isn't it sine and cosecant reciprocal? So if I multiply something by its reciprocal, it's always equal to 1. Now this is just like last example. I see two different pieces and cosecant itself. Cosecant square itself has a rule. So I could just integrate right away. But don't forget, you need to integral every single piece. What's the integral of cosecant? It's negative cotangent square x. Integral of 1 is x, and I would add c at the end. So yeah, that's all for today. And if you need help on anything, comment, and then I'll help you with that. Stay safe and bye-bye.